Okay, students, I hope I find you well. Just want to have just a quick review of a question involving apparatus that we use in chemistry and very simple processes that we may be asked. Such questions you cannot afford to miss the marks. These are marks for you, and it should be straightforward. Like I always say in paper six, don't beat about the bush. Okay. So in this question, you have a piece of limestone which was added or which was heated strongly for 10 minutes. The solid was then left to cool, meaning to say maybe this solid underwent a process which we can call thermal decomposition. So the examiner is expecting you to be able to identify the apparatus that we are using here. Okay. I suppose from your teachers, from your lab sessions, okay, the apparatus that we see here, okay, this one is called a pipette, okay, pipette, but obviously some people can also include the word teat, okay, teat, but that is an additional, okay, that's the complete name. We call it a teat pipette, okay. We use it in the lab. When you squeeze, liquid actually comes out through there. Okay, and then we have this apparatus down here where we are having our lime, which is also calcium oxide. Okay, obviously this one, I suppose you are familiar with that one. This one is where we normally evaporate stuff, so we call it an evaporating dish. This one, we call it evaporating dish. Okay, and then before we leave this, please be aware of the fact that limestone is calcium carbonate, okay? And lime is calcium oxide, okay? That's also information you can use for your major theory paper. Limestone is calcium carbonate and lime is calcium oxide. So if limestone calcium carbonate undergoes thermal decomposition, it's changed to lime, which is calcium oxide. Okay, let's move on. Right, let's remove this, otherwise it will confuse us. Suggest what could be used to hang the piece of limestone from the stand over the heat. Explain your answer. Okay, right. We want to perform what we call thermal decomposition. So obviously, the ideal material that we can use here, any metal. Okay, so what we could say here is any metal. All right, so we can use wire. Okay, metal that can, okay, stand that can withstand high temperatures, okay? As long as you have any metal that can withstand high heat or high temperatures, okay? That could be your answer here. So the thing suggests what could be used to hang. So we use a wire. Obviously, we're not going to use a piece of thread, okay? So it's more of common sense question. We want a metal or a wire that can withstand high heat. Why 2 marks? Okay, we need to be able to find out from the student whether they know that we are not going to use a piece of string. So it has to be a metal or a wire. First mark. Second reason, it must withstand high heat. So that's why we have 2 marks there. In what position should the air hole of the Bunsen burner be? Okay, remember, Bunsen burner can give us 2 types of flames. If you close the whole of the Bunsen burner, you are limiting air supply. There's incomplete combustion. Check the flame which should be produced, okay, to be orange and huge. Next time you go to the lab, students, please check this. Close the air hole of the Bunsen burner, you produce a large orange or yellow flame. Not very hot, okay? It's highly luminous and it's wavy, okay? But if you open, there's now complete combustion. You can actually hear a sound and the flame changes to blue. If it's during daylight, sometimes you not even be able to see it because it's non-luminous. Okay. And also, if you put your beaker for the for the luminous flame, you're going to see carbon or soot forming at the bottom of the beaker, simply because there is incomplete combustion. So for us to have thermal decomposition here, we need a lot of heat. So in what position? We don't beat about the bush again. We are just going to say it must be open to allow maximum oxygen to interact with our gas. Okay, right. So that should be our answer there. Okay, we move downwards. Okay, predict the effect of solution A on pH indicator. Right, the examiner here is testing your knowledge on metallic oxide and non-metallic oxide. We have calcium oxide here, okay, being produced, and we're going to say calcium oxide plus water. Okay, calcium oxide plus water. And then what are we going to have there? We're going to have a base because it's a metallic oxide. So obviously, our answer here, pH must be bigger than 7. Okay, so we can simply say here pH, okay, pH greater than 7, okay? But we want to have an observation. What are we going to see here, okay? Blue solution, okay? Blue solution, all right? Or you can actually say blue solution, or you can actually say here, dark green, okay? Dark green is acceptable. Dark green, as long as you're mentioning any solution which is associated with pH which is greater than 7, that should be fine. Dark green solution produced, okay? Right. So purple is okay, but blue will be more ideal. All right. So predict the effect of carbon dioxide on solution A. All right. Remember, the test for carbon dioxide is lime water. Okay. So we have actually made lime water if we add the solution calcium oxide plus, okay, plus water, we have calcium hydroxide. And calcium hydroxide plus carbon dioxide, we go back to calcium carbonate. And the milky white or cloud suspension, the white precipitate that we see there is actually calcium carbonate. So if we put carbon dioxide on solution A, what you are simply going to see here will be that white precipitate, okay? So be familiar with the terminology for paper 6, okay? Right, precipitate, all right, precipitate, white precipitate produced, white precipitate produced. You can say cloudy solution also being formed. That is our answer there. Milky, white precipitate, cloudy solution being produced. And that would be your answer. Okay, right. So paper 6, like I always say, short answer with the right terminology, you'll be in a position to score very high. And then when you do that, you have your 7 marks. This was question number 1. Okay, I thought I should just review this question with you, which has to do with chemistry apparatus. Next time, when you're in the lab, find out what the teacher will be saying about the names of the apparatus so that we'll be in a position to address such questions without much challenges. Thank you. Bye-bye for now.